So let's start with construction of the DFA for a given language. Now we can say that DFA M recognizes language L when language of the DFA is equal to given language. If W belongs to L, W belongs to L of M. Every string W which is in the language should be accepted by the DFA. If W does not belong to L, W does not belong to L of M. Every string which is not in the language should be rejected by the DFA. Now let's consider one example. Alphabet contains A and B. Now when you design DFA, at every state you have to handle transition for every symbol in the alphabet. So always pay attention to alphabet. Do not ignore any symbol in the alphabet. Let's come to the language description. Language L is W such that W contains at least one A and at least one B. So always pay attention carefully to the language description. Here there are conditions. W should contain at least one A, at least one B, and there is AND condition. Now the next thing is that before starting with construction of the DFA, always consider few strings which are in the language and which are not in the language. Always start with epsilon. Now if you consider string epsilon, then epsilon is null string. It does not contain A, it does not contain B. So epsilon is not part of the language. So if you consider strings like AB, BA, AABAB, BAA and so on, these strings are part of the language. Strings like AA, BBB, which contain only A or only B, they are not part of the language. So let's start with construction of the DFA. So we take start state P. Now on A, we go to state Q. And after seeing B, we go to state R. So if DFA takes this path A, B, then we have found at least one A and at least one B. That's why we go to state R and we have marked it as a final state. The DFA is not yet complete, but in this path from initial state to state R, we have found at least one A and at least one B. So this state must be final state. Now here string can start with A, it can also start with B. So can we do something like this? On B we go to Q and after we see A we go to R. So this is not correct, because in this DFA if we consider if we consider string AA, then after processing AA from initial state we reach a final state and string AA is accepted by this DFA, whereas string AA is not part of the language. The reason over here is right now state Q cannot differentiate whether A has occurred before or B has occurred before. If A has occurred before, after seeing B we should go to final state. If B has occurred before, after seeing A we should go to final state. But here state Q cannot differentiate. So for that reason we have to keep these two paths separate. So we add a separate path. If the string is starting with B, we mark it as state S. After seeing B, if we see state A, symbol A, then we go to final state. Now here right now Q handles only one single A, exactly one A, and the condition is at least one A. So at Q we add this loop. So here now state Q handles at least one A. At state S we add similar loop for B. Now let's look at significance of all the states. Say significance of state P is nothing is processed yet, but at state P we add two separate paths for strings starting with A and strings starting with B. Significance of state Q: if the processing has reached state Q, it means at least one A is processed. For state S, significance is at least one B is processed. For state R, from P you can reach R either by this path or by this path. But if you reach to R by any path, then at least one A and at least one B, they are processed. So anything comes after that in remaining part of the string, it must be accepted. For that reason, we add this loop A comma B, and this is our required DFA. So at every state we have handled every symbol. At P we have handled A and B. At Q we have handled A and B. At S we have handled A and B. At R also we have handled A and B. Do not ignore the notes. You will understand some points easily and clearly if you go through the notes. Now let's take some example how strings are processed in this DFA. If we consider string A, A, B, A, B, then processing starts at P. Now when we process this A, we reach to Q, then this A, we remain in the Q itself. At B, we go from Q to R. Now here we have reached the final state, but the string processing is not complete. Whether the string is accepted or not is decided only after complete processing of the complete string. So after processing this B, we reach to state R, and then this A is processed in R itself, this B is also processed in R itself. R is a final state and this string is accepted by the DFA. Now if we consider string AAA, then we start from P. At A we go to Q. For this A we go to Q, and then for subsequent A's we remain in Q itself. So for this A we remain in Q, for this A we remain in Q itself. So processing of string AAA ends in Q. Q is a non-final state and this string is rejected by the DFA. So every string which is part of the L is accepted by this DFA. Every string which is not in L is rejected by this DFA. So this DFA recognizes language L.